What's up guys, welcome back to one more video. On this one we're going to explore the Pentium MMX 166 and do some comparisons with the 46 Rust bucket that runs at 160 megahertz. I mean 160 versus 166 megahertz, how much more performance can those 6 megahertz get the Pentium MMX? Well, we'll see. Released in 1997, the Pentium MMX sits one tiny step ahead of the regular Pentium processor between the 486 and the Pentium 2. The Pentium processor already implemented many features on top of what the 46 processors were doing, like superscalar architecture that allowed for 2 instructions per clock cycle. 64-bit external data bus. This means that the Pentium can fetch twice as much information each time it accesses the memory, and it has faster access to storage and to floating point data. This will be important for games. Speaking of floating point, the Pentium had a major boost in FPU instructions, and I mean huge. Some operations it does 15 times faster than the 46. And these were only a few of the improvements the Pentium had over the 46. The Pentium MMX we're talking about added, well, the MMX instruction set that was advertised as being a set of instructions made for multimedia. These instructions aided on encoding and decoding digital media. With this, Intel pushed expansion board makers to delegate more and more to the CPU. If you'd like to see this in more detail, there's going to be a link on the description to a video about MMS technology done by the Nostalgia Nerd that explains this much better than I could ever hope to do. There are 2 major points to be noted about MMX technology. It's only used by software that was specifically designed for it, and also in the Pentium, MMX isn't used simultaneously with the floating point unit, so that makes it a tough sell for 3D games like Quake. That was addressed later by SSE, but that isn't on the scope of this video. And on the subject of Quake, it heavily relies on the FPU instructions. Why? I'll give it a try, but this is going to be another really simplistic explanation that you shouldn't quote. Quake is said to be the first real 3D game, as the maps are made of 3D objects, and as you know, our monitor displays a 2D image. So to transform those 3D objects into 2D images to be displayed on the monitor, there needs to be perspective calculations based on the point of view of your character in the game. On a step before all that, FPU is also used when code is transformed into 3D objects. So good performance on operations of this kind are a must for games like Quake, and this is exactly what we got moving from the 486 to the Pentium processor. Okay, time merges and we must move on to the computer at hand. This is the computer we're taking a look at today. It sports a pretty neat Acer Socket 7 motherboard with a Pentium MMX 166. It also houses a Sound Blaster AWE64 and a PCI Trident TGUI 9440 video card. Originally, it carried 32 megabytes of EDO RAM memory, but that has recently gone to the Rust Bucket 486, and the Pentium MMX that has DIMM memory sockets got a 128 megabyte stick, and it only shows 64 megs, so I'm guessing the limit for each memory slot is 64 megs of RAM. And right as the computer boots, it comes up with the Cmos low battery warning, and this computer for some reason won't let me go past that. So we're going to have to address that right away. And now this motherboard doesn't use a regular 2032 battery, it uses this ancient thing. This thing here is a battery and a clock, and you can't just buy them anywhere, so I almost lost it here, but Necroware on YouTube comes to save me, and he has a video on how to hack this thing to use an external battery source. I'll link his awesome explanation in the description, but basically you need to drill the right spots and solder wires for the positive and negative sides of the battery, and there you go, that's all you need. It would be ideal to solder a 2032 battery socket, but I don't have one, so that will be a problem for future Sucra. Since I don't have the battery socket, I used electrical tape and a plastic fastener to hold the battery to the wires. So the Pentium is back together and ready to boot in a Windows 98 installation. Thankfully, the Pentium is modern enough so that it can boot from a CD-ROM, and for that, I went into the BIOS to change the boot order, and I was surprised by this cute mouse cursor with a wiggly tail. For you guys that are watching, it probably seems like these videos take about 10 minutes to make, but they take several days and many hours of filming. The day I did the battery mod, I had planned to install the OS and at least one game so I could see how the system performs, but because of all the battery shenanigans, I was late a day and needed to capture all the games on Wednesday so I can edit on Thursday and upload the video on Friday. And to make matters worse, I don't have my vehicle. It's broken down at the mechanic's shop. But on the last day of filming, I took the Metro and got to the lab early to install the games and capture playtime on all of them. It's going to be a long day at the lab, but since the computer is ready and I already know the games I want to test, it should be all good. First thing, I want to test the games that didn't run on the Rust bucket, so Half-Life and Unreal. Of course, the Pentium doesn't have an accelerator card yet, so everything needs to run on software mode. Regardless, at this point in time, around 1997, it wasn't expected that every gamer had a 3D accelerator, so all games from this period should run in software mode. The original Half-Life was released in 1998, and of course you can't expect it to run in a high resolution in software mode. But I'm glad it works. Here at the mind-boggling resolution of 320 by 240. But definitely a better job than the Rust bucket, I could actually get to the end of the intro sequence and start the game. Funny thing, because the 46 Rust bucket runs this game so slow, I thought the intro sequence was long, but it's pretty quick on a decent computer. I did switch the resolution to 640 by 480 for a bit, still in software mode, and the game looks so much better. Also, the capture card doesn't like very low resolutions, so it works better like this, but the game is just too slow in this setting. Unreal we ran at an even lower resolution to get the game reasonably playable. Here it's running at 320 by 200 and I actually feel bad playing the game this way. It's such a beautiful game and the 3D mode in software makes it look like crap. But it's playable, sort of. So again, I did switch the resolution up just to see what the game looks like. Still, it's not as pretty as in 3D hardware accelerated mode, but a lot better and definitely unplayable at 640 by 480 in software mode. On the original form of the Rust bucket, we ran MS-DOS Star Wars Dark Forces from 1995, and I was surprised at how good that game looked. So here, we're gonna try Dark Forces 2. Released in 1997, this is your basic shooter but with the Star Wars theme, and it looks very good. The game was running fine at lower resolutions like 320 by 240, but when I raised the resolution to 640 by 480, the capture card said no, you're on your own. So I asked my brother to poorly film the screen so that you can see that this game looks good and runs well at 640 by 480 in software mode. Granted, restricting the view size helps a lot. Hexen 2, being a clone of Quake, ran with no issues at 320 by 240. This franchise never really got me though. I was a bigger fan of its brother, Heretic. Like Hexen 2, Heretic 2 uses the Quake engine, but the game is in third person and they made so many changes in the game engine that you can hardly recognize the Quake engine within it. Hexen 2 is another game that I'm doing a disservice by running in software mode. This game is kind of quirky and cool with its magic third-person shooting style. But of course, our venture into software 3D rendered games in the Pentium MMX wasn't without its failures. Here is Shogo Mobile Armor Division, basically my favorite game from that time, and it's quite unplayable even at 320 by 240. This game definitely needs a hardware 3D accelerator. I installed Diablo 1 and 2, and the original Diablo was impossible to see. I used an LCD monitor at the lab and it just couldn't make out the Diablo 1 game signal. Well, the capture card couldn't either, but that was a bit different for Diablo 2. That one I can see in the lab PC with the capture card, but the LCD monitor refuses to display this game in this form as well. I think it's because it expects a much higher refresh rate for lower resolutions, and since some of the games here can't achieve a decent FPS even in lower resolutions, I'm bound to have this problem until I get a CRT monitor for the lab. So that was it for this video, but we're definitely not done with the Pentium MMX. Next week is going to get the Voodoo Graphics video card that we used on the 46 Rust bucket, and the games are going to look a hell of a lot better with higher resolutions and texture filtering. But that was it for today. I hope you got some useful information or at least had some fun. Don't forget to subscribe to the channel, like the video, or dislike if I offended you somehow. Click the bell icon and I'll see you next time.